I'm going to explain problem 2 because I got a lot of questions on how to do it. So in problem 2, if I look at the problem over here for a minute, so in part 1, we're going to create this matrix through 3 functions, I, ones, and try. And as I explained in class, you can easily use these functions as follows. So let's say for n equal 10, I write as I, which is the identity matrix. So this creates an identity matrix. And then to create -1 in the upper triangular part of it, I use this try_u function, which creates upper triangular matrix. I fill all of the elements with ones. So this piece actually creates upper triangular matrix whose elements are 1. And then I multiply by a negative sign, so I get all negative ones on the upper triangular part. Then I'm going to add it to the identity matrix. So then down the road, this A would be exactly what I want to be. So let's see, if I run this code up to here for a minute. Okay, so I actually forgot to display the result. So let me quit and rerun. So here we go. We get all ones on the diagonal and then -1s on the upper diagonal, all right? So next is part 2. So let's look at part 2 here. Part 2 says, okay, we have to prove the condition number is n times 2 raised to the power of n minus 1. All right. So to go about doing this, what we can do is, okay, let me comment this out because we don't need it. All right, so remember in class we had the definition for condition number over here. Condition number for a matrix can be written as the norm of matrix A times norm of inverse of A. All right, now let's do each part separately. What is norm of the matrix? Okay, so by definition, norm of A is, okay, let's say norm 1 is maximum column sum of absolute value of the elements of A. In other words, let's say for this 10 by 10 matrix, I can easily do some absolute value of A, and what I get is the following. So let me run that up to there. Here it is. So if you put n equals 10, this would be sum of columns for which you got the absolute value of the elements. And you can easily see the pattern. So if you put n equals 10, it goes from 1, 2, 3, 4 all the way to 10. Now you can imagine if I put n like a generic n, this vector would be 1, 2, 3 all the way to n, right? Now, the norm of A, again, by definition, is the maximum of these elements, right? So if I do with n elements, you can easily see that norm of A, okay, so let me write that over here. So then norm, well, let me put it this way, norm of A is equal to n, right? So this is what I proved so far. Hope it's clear. Now, the next piece is norm of inverse of A, okay? So let's get the inverse of A, see how it looks like, and then we use the same definition of maximum column sum of absolute values, okay? So let me stop it here, comment this out for a minute, okay? So let me run up to there. Okay, nothing happened. Let me show you what inverse of A would look like. So this is inverse of A, all right? Now I have to do the column sum over all these columns. All of these are positive, fortunately, so you don't need to take the absolute value, okay? Now, if you do the sum of absolute value of inverse of A, actually this does the column sum for you. And if I do step, there you go. So this is the sum, right? Now, again, you have to be very careful, and find a pattern. For n equals 10, it goes 1, 2, 4, 8, 16. Looks like every time you multiply an element by 2, right? Anyways, the maximum of this row vector is actually 512. And so 512 is a power of 2, right? you can easily figure this out, is actually 2 raised to the power of 10 minus 1, which is actually 9, right? Look at that. So if I put n equals 10, the norm of inverse of A, which is the maximum of these elements, is 512, which can be written as 2 raised to the power of 9, or 10 minus 1. Now, for generic n, it will be 2 raised to the power of n minus 1. Okay? So, and this is what I've written over here. Okay? So I proved so far, norm of A is n over here. Norm of inverse of A is 2 raised to the n minus 1. So the condition number of A would be the multiplication of these two, which means n times 2 raised to the power of n minus 1. And this is exactly what I want you guys to prove. It's over here. All right, let's move on to part 3. Well, we are looking for n such that condition number exceeds 1 over epsilon, and epsilon is, 2 raised to the minus 52. Okay? Now, for part 3, it's actually not very hard. So we've proved in part 2 that the condition number is n times 2 raised to the power of n minus 1, and we have to find n such that it is less than 2 raised to the power of 52. Correct? Now, well, you can start with a guess. I mean, the very easy guess would be if I put n equals 53, right? Then I get, what do I get? So if I put n equals 53, then I'm basically doing 53 times 2 raised to the power of 53. So raised to the power of 53 minus 1. All right? And you can subtract this from 2 raised to the power of 52, right? If this is positive, then your n is okay, but we want to look at the minimum n such that it exceeds this equation exceeds 2 raised to the power of 52. Okay, now 53 is an easy guess because, the way I guessed it is because I said, hey, okay, on the right I have 2 raised to the power of 52. Why not just make this piece, 2 raised to the power of 52? And that means n should be 53, right? So let me run it over here and then see how it goes, right? So here it is. Okay, so you see the difference is positive. So that means I can reduce n. I can go to 52. Okay, still is positive. I can do 51. 51. Still is positive. I can do 50. Maybe let's do 49. 49. Okay, I can do maybe 45. Okay, let's see. Okay, got negative, right? So that means it has to be greater than 45. So let's say 46. Still is negative. I guess next would be 47. All right, so still we are negative. We have to go and do 48. And there you go. So with 47 you get negative, with 48 you get positive. So 48, n equals 48 is the minimum n, excuse me, such that norm of or condition number of A is greater than 2 raised to the power of 52, which in other words is same as saying condition number of A is actually exceeding 1 over epsilon with n equals 48. All right, so hopefully this makes things clear about problem 2 of homework number 1.